Alright, Bismillahirrahmanirrahim. Students, let's do a very brief analysis of truss analysis. Okay, we start with some structural analysis. One of the simplest one is truss analysis. Okay, so I'm trying to do some sort of a simulation, computer simulation for truss analysis, so that if in future you're being given a task to solve some sort of truss structure, it can help you. Okay, so truss is basically a structure composed of slender members joined together at their endpoints. The members are commonly used in construction of wooden struts or metal bars. Okay, so the plane truss is basically lying in a plane and are used to support the roofs and bridges. Okay, so in these structures, the roof load is being transmitted to the truss at the joints by means of purlins. Okay, so that is how the load is being transmitted. So again, this is the roof. The top one, you can see the roof, and the load of that roof is being transmitted to the purlins, and then it is being transmitted to these truss structures. Okay, here it is. You can see these points, and these are the joints over where the load is being transmitted, and the entire structure is resting on 4 columns, and the columns are you can see on top of the columns there are supports: the pin support, the roller support, the pin support, and the supports are very important as they give basically reactive forces to this truss so that it maintains its stability. Okay, then if you see any basically bridge truss, it will be made up of these components over here. There is a deck on which the cars can go, the rails can go, and it is called as a deck. And then these horizontal structures are called as the floor beams, and these long structures, okay, these long structures are being termed as the stingers. Okay, so this is the same example, bridge truss over there. These and these 2 points are basically the rollers, and this is the your pin, and these are the points on which the load is being transmitted of the car or train at these points. Okay, from the stingers and the floor beam that is being transmitted to these joints. So let's go and see, and always remember the loads along these the loads will always be transmitted at the joints. Okay, it will always be at the joints. It will never be at the midpoint of the loads. Will never be like this. The loads can be vertical, the loads can be horizontal. So, and they are always placed at the joints, and these loads are transmitted as tensile. Either if this member will always have a load which will be either tensile or compressive. Same with this along. So it will be basically a tensile load along the member or compressive load. Okay, let's do a simulation like here. Determine the forces in each member of the truss shown and indicate whether the members are in tension or compression. So this AB is 2 meters long, BC is 2 meters long, and AB is 2 meters long, AC is 2 meters long. So this AC will be at 45 degrees to AC. This is the 500 Newton. Our task is basically to calculate the force in AB, the force in BC, the force in AC, the roller reaction force, and the pin support reactive force. Okay, this will be our task. So for this we'll use the software called MD Solids, and let's start solving the structure. Okay, so if you look at its structure, let's start it from the start, very starting. Okay, so this is how we start this, and let's go here, and if you go here, we say it's a new truss, and for this we have to basically select the proper scale. We say that we have to assume that horizontal spacing of the structure will be 1, number of the individual horizontal spacing interval, and the number of spaces that I will define as 2, and same the vertical spacing interval I will say also 1, and the number of spacing I will define as 2. Let's go and see. Okay, so this has been done now. Now if you look at it, this was our actual drawing. Okay, so 2 meter by 2 meter. So if I say from this point create a member for 2 meters on the y-axis, and also create a member. You look at it. This will also be of alright. Just we will try to make it more clear over here. Just wait. We erase it, and erase it like this. Let's go to. We say that the horizontal spacing again will be 1 based on 1, and number of spaces we can define it as 4, and again we say the vertical spacing interval is again 1, and the number of spaces is 2. It will be more precise and similar along x and y. Okay, so that will be more better for us. We can do in that way also, but let's go for create. So we create members. We have got how many members? 3 members. 1 member here. The other member is also 2 meters. You can see this is 2, and from here this is 2. The third member will be at, I think if we do it correctly, it has to be at 45 degrees to the base member, and that it is. So these are the 3 members which we have created, and then we have to have a pin member. Okay, for pin or supports, here it is. Let's define them, and we say this is the structure. So, and the roller support is also here, like this we define it, and then they say you also need to support load. So I think the load is of 500 Newton. Yes, I think so. It is 500 Newton, and we enter the load. So have we made the structure very clear now? If you look at it, is it exactly like this? Yes, it is exactly like this, and now we can ask the software to calculate it for us. If it is complete, let's tell the software to do it for us. Okay, so he has solved it for us. So the force in BC, this member, is 707 newtons. The force in AC, vertical member, is 500. The force in AB, the horizontal member, is 500. These two forces are the pin supports. AX 500, AY 400, and BY is also 500. And you can see these reaction forces here also, AX, AY, BY. Okay, so there are very tough analytical calculations for truss, but from this software you can very easily calculate it in your future assignments and calculations. If you can see the results, this horizontal force BC is 707 newtons. This AC, so AB is 500 newton. You can see AB is, I think it was, you can see, it's 500 newton. AB is also this horizontal component force is also 500 newton. So these both 500 newton. This one is also, CA is 500 newton. Vertical force CY is 500, and AX AY is also 500. So you can see these forces. AX AY is 500. This is CY. Okay. Now, but this force, vertical force, is basically compressive, and if you look at it, AX and AY are tensile forces. Okay. This is a tensile force, this is a tensile force. Okay, remember this thing along the point A. And if you want to further elaborate the directions, you can ask the directions at these 3 points. So this is a simple calculation. I will make another video on doing tough computations of trusses. Okay, it will help you in your future assignments. Thank you.